In this section, we look at establishing enterprise radio access network solutions, in which we introduce how mobile networks can be utilized to enhance enterprise services. A large number of enterprise networks rely on a single network service provider solution that may be in some cases protected by a service level agreement or SLA, as protection where downtime is likely to be critically damaging to a company's operation, and also where supporting multiple networks is unnecessarily costly. Traditional approaches involve failover solutions using technologies such as ISDN. However, newer and more viable solutions in the form of cellular technologies provide effective failover measures in the event that the primary networks fail. This section introduces how 2G and 3G cellular network failover solutions can be used to protect the enterprise network. So upon completion of this section, it is generally expected that trainees will be able to explain the application of 2G and 3G networks as an enterprise failover solution, as well as explain the process for implementing cellular interface failover solutions. With the continued successful growth of mobile communications, we have also seen a continued evolution of the services that are capable of supporting not only calls, but also data services that are making big waves in terms of the type of business and services that many industries are able to offer to customers. The means by which these services are possible is the wireless wide area networks, or W1, that we are familiar with as a result of service terminologies such as 2G, 3G, and even 4G LTE. It is this wireless WAN infrastructure that we wish to initially look at in order to understand its application for supporting enterprise networks. The architecture itself is made up of a circuit switch network that handles call routing, and a packet switch network that we can understand as supporting data communications. Managing these is what is understood as the core network that manages much of the call services and process management. Signals are basically carried from a user's mobile handset device through the radio access network to a receiver before being processed and forwarded to the relevant services. But the question we may be asking is, what relevance has this to the enterprise network? Well, as a result of the continued growth of mobile networks and its data services, we are able to support an extended reach of network services to reach remote employees and allow for true mobility of the enterprise network beyond the physical boundaries of the office. One of the limitations has been primarily with transmission speeds. However, with the continued push for more data capacity over the network, the mobile network is enabling new opportunities for solutions for the enterprise network. The enterprise network is able to utilize the current packet switch data networks of the mobile network to provide network failover solutions in the event that the primary network fails. As a primary solution, the wireless WAN is considered too costly. However, as a backup to the primary network, it is considered ideal. As such, it is possible for the enterprise backup solutions to be implemented over the 2G or 3G based networks, where it is important that continuity of business operations be supported. In order to be able to support the implementation of failover solutions for the wireless WAN, special modules are required that support communication over 2G and 3G services. We show the typical module card that is used for supporting these services here. For those devices that are commonly housed in a cabinet or rack, indoor remote antennas may be used in order to ensure the signals for 2G and 3G services can be discovered. It is also required that a 3G modem be used to support the modulation of signals over the cellular network, and is connected to the display 3G HSPA module via the USB port highlighted by the letter B. To allow the router to operate as a failover device for the wireless WAN, we must configure the device to support connectivity over the router's cellular interface. We will recall from the configuration of the PPPoE services that the IP address PPP negotiate command implements the use of the IPCP protocol to negotiate a remote IP address with the peering device. A profile may also be created that specifies the access point name, that is basically the gateway for the 3G network in this instance. We additionally set the mode that is to be used, in which we clarify that we wish to connect using the WCDMA standard in this instance, and state that the WCDMA networks should be preferentially used in this case as opposed to using GSM networks. The alternative mode involves using the CDMA 2000 standard. We are able to use a dialer rule in order to initiate the connection that allows traffic to be carried over the 3G network. This is configured as part of the dial control center that manages the activation of the connection over the 3G network. The dialer rule here defines the connection will support IP traffic, and following which we are able to configure parameters for the interface. There are two supported modes. The first is the Resource Shared Dial Control Center that was used to support the establishment of PPPoE when using DSL networks. The alternative is the Circular Dial Control Center that is better suited to supporting failover connections, but cannot be implemented where a router is a PPPoE client. We see here the circular dialer is configured using the dialer enable circular command. We also create the dialer group as well as assign a dialer number that is used to call the remote end. Since we are required to support hosts that are considered part of an internal network, we must implement NAT in order to allow private addresses to be translated before reaching the external network. This is achieved through the defining of rules, which are associated here with the NAT outbound command on the cellular interface and ACL number 3002. If no other route is available due to the primary route failing, we must ensure that IP traffic is redirected to the cellular interface to be carried over the 3G network. This is achieved through the default IP static route, which, as we can see, will route traffic to cellular interface 0/0/0. We can verify the current status of the cellular interface configuration and support of the 3G failover network using the command display interface for the cellular interface over which failover is performed. We should find that the state is considered up and that an IP address has been negotiated, which we can see here as the address 203.161.70.97/32. The modem state will be used to determine whether a 3G modem has been connected to the 3G cellular interface module, and where connected will show as present. We must also ensure that the network address translation has been correctly configured over the cellular interface. Using the display NAT outbound command, we are able to see that the NAT configuration has been associated with the cellular interface and that the ACL rules have been bound to this instance of NAT, which, as we may have noticed from the NAT outbound command, is supporting EasyIP to allow internal hosts to be mapped to the PPP discovered cellular IP address. So in summary for this section then, we just have one question here, and it asks, how is failover to the cellular network supported in the event of a failure of the primary network? Well, the configured default IP static route will act as a last resort for the traffic in the routing table, and should it be used, will forward traffic to the cellular interface. This will cause the dial control center to initiate the failover connection over the cellular interface with negotiation performed using PPP.